taking a look at the harder problem that uses this reaction. And reading off the given information, it says that there is going to be an initial concentration of one of these items, just the ammonia. But what it gives me of the ammonia, if you read the problem, is it says that we have 12 grams of ammonia. All right, but of course in my I row, it needs to be a molarity. So I need to start tiptoeing towards getting a concentration, and grams, of course, is no good. So let's turn grams to moles, since I know that molarity is moles over liters, all right? I can use that equation to get the molarity that I need for the I row. So I want to go from grams to moles, so I'll make the diagonal match. Anytime moles is over grams, it's 1 to periodic table. So we need to add up the mass of 1 nitrogen and 3 hydrogens, and it comes out to 17.03 after finding that molar mass. All right. And this is going to give me 0.7 moles. All right. Now again, I want to use this equation to go moles over liters. And if you go back to the problem, it tells you 2.5 liter bottle is where this reaction is going to happen. All right. So I can follow my equation and say, okay, well, 0.07 moles divided by the given 2.5 liters is going to give me a concentration of 0.28. So there's my starting concentration. One moment. Thank you so much. I appreciate it. Happy Friday to you. So we're going to insert our concentration here into the problem. Now, as we start doing our I row, though, I want you to notice something. We have a solid here. And of course, a solid can't go into equilibrium. So I'm just going to put a big X right here because solids and liquids are not considered in any part of a rice table. So it can just be completely ignored. But these are gases, so now we can go. So we said the initial concentration of the NH3 is 0.28. All right, and then the initial concentration of the other product, of course, will just start at 0. All right, so my shift is going to go towards the 0. So we know we're going to be shifting this direction. All right, so then this will be plus and plus. All right, bring down the coefficients. There are none, and we can just bring down the x's. And then, of course, row E is going to be I plus C equals Z. So let's go 0.28 plus x here, and then this is just x there. So the question itself is looking for the equilibrium concentration of the carbon dioxide. So it just wants that number there by looking at the problem. The other given information that we haven't used yet is it tells us Kc. It says that Kc is equal to 1.5 e negative 2. That's our extra information. So now we can start using an equilibrium expression to figure it out. So this is not a Chatelier problem because of that 0, right? The only way I would need to solve for Q is if I had concentration amounts for everything. So let's set up my unsubstituted equation, which is going to be Kc is going to equal NH3 concentration and the CO2 concentration. The reason it's this simple is because there is no reactant to put this over, so I'd put a 1. We always do a placeholder. So it would be all of this over 1, but anything divided by 1 is itself. So this is a simple enough expression. There are no exponents because there are no coefficients. So let's plug in. We have a Kc of 1.5 E negative 2. And I'm going to set that equal to the NH3 equilibrium, which is 0.28 plus X. And then the carbon dioxide is just X. All right, we can start to simplify this, which will be 1.5 E negative 2. I'm going to distribute this X into here. All right, that's how they'll multiply. So it'll be 0.28X plus X squared. All right, X times X is X squared. X times that is that value. And now I can see a quadratic forming. So what I want to do is move him over here, because if I do that, it'll become a 0 equals expression. All right, and then I'm just going to make this look pretty. So these two things will keep their sign, right? The X squared will stay positive. All right, the 0.2X will stay positive. But since he moved over, he's going to reverse his sign, so it'll be minus 1.5 E negative 2, right? Because that's how you get him over there. You'd subtract on both sides. So there's my 0 equals expression. And now, of course, we cheat because we don't want to do a quadratic. So let's go to our handy-dandy math and then scroll down or cheat up to solver. There's my 0 equals. I'm going to go alpha to get to an X, hit the squared button, plus 0.28 alpha and X again, minus 1.5 E negative 2. So there's my entire expression. Put in a guess of 2 because we always do that, and then alpha solve on my calculator. I want to hit the solve button. All right, and I get a final X value of 0.046, which will be the answer to the problem because remember, we're looking for carbon dioxide, which at equilibrium was just X. Therefore, this is